Hello and welcome to problem 7 in my Calculus 3 or Multivariable Calculus problem solving series. In this video, we're going to look at how to find a unit tangent vector to curves in 3 dimensions. So this problem asks us to find the unit tangent vector of r at t equals pi over 2, where r is the vector valued function cosine of t, comma sine of t, comma t. So for every t, which is the parameter of this function, it gives us a vector in space, and this produces a curve. And this specific vector valued function gives us this curve that's called a helix, and sort of looks like a spring that goes both up and down. So how do we find the unit tangent vector? Well, the unit means that its magnitude will be equal to 1. And tangent means that it points in the direction tangent to the curve at that moment. So how do we find the tangent vector? We have to take r prime of t. And the reason that r prime gives us the tangent vector is because r prime is the slope. So by getting the slope, we get the vector that's tangent to the curve at that point. So how do we get r prime? R prime, since r is cosine of t, comma sine of t, comma t, then r prime is negative sine of t, comma cosine of t, comma 1. And when we plug in pi over 2 into r prime, then we get negative 1, comma 0, comma 1. Now to get the unit tangent vector, we need to divide this vector by its magnitude. By dividing the vector by its magnitude, we're essentially getting a unit vector. So that's what we do here. And we get the vector, the tangent vector on the top, and on the denominator, we have the square root of 1 squared plus 0 squared plus 1 squared, which is the components squared, the components of the unit tangent vector. And that gives us this vector. And then this is the unit tangent vector at when t equals pi over 2. So this vector has a magnitude of 1 and points tangent to the curve. So that's all for this video. Thanks for watching.